We're going to solve this system of equations by substitution. I'm going to take this y equals x plus 9, and I'm going to plug that x plus 9 in up top where there's a y. So I'll have x plus 2, and instead of writing y, I'm going to write that x plus 9 equals negative 6. And I can distribute and solve. So that would be x plus 2x plus 18 equals negative 6. Combine my like terms, that's 3x plus 18 equals negative 6. I subtract the 18, that would be 3x equals negative 24. And I divide by 3 on both sides and get x equals negative 8. So remember, when I'm solving these systems of equations, then I've got an xy answer. So I've got negative 8, comma something, and I can plug in that negative 8 into either one of those equations. That bottom one looks easier to plug the x into, so I'd have y equals, and instead of x right there, I'm going to put this negative 8. So I've got negative 8 plus 9. That would be y equals 1. And I could have plugged it in up top, so this is my answer right here. I could have plugged it in up top for x right there and got negative 8 and solved it that way. Got the same exact thing. I would have added 8 over and got 2 and then divided by 2 and got 1. I want to show you this on Desmos. So I've got x plus 2y equals negative 6. X plus 2y equals negative 6. And I've also got y equals x plus 9. And if you'll notice on my graph, the point where those two lines intersect at would be negative 8, 1. That was really convenient. Next, this one's not written in, one of them's not in like a y equals mx plus b kind of form, or y equals something, or even x equals something. But I do notice up top, it says that x minus 6y equals negative 13. And in my mind, I'm going to rewrite this one. I'm going to add the 6y over and say that one's x equals 6y minus 13. So all I did was rewrite that top one as x equals 6y minus 13. I added that 6y over. So I have x equals this stuff, and I'm going to insert that 6y minus 13 right there. I'm going to substitute it in for x right there. So on that bottom equation, instead of writing 4x, I'm going to write 4 times 6y minus 13 minus 6y equals 2. And I can distribute that. That would be 24y. That would be minus 52 minus 6y equals 2. Combine my like terms. That would be 18y. We'll go ahead and add the 52 over the other side. So add 52, add 52. So 18y equals 54. And I think that's going to give me 3 once I divide. So that would be y equals 3. What's important here is that, this is an xy point, and make sure, since you got y equals 3, make sure you plug it in right there where the y is. Don't punch it in where x is. So I got y equals 3. To get the other point, I'm going to say, I can punch it into any of those. I'm going to punch it into this version of the top equation. So I'm going to say x equals 6 times 3 minus 13. So that 3 was right there where that y was. And that would be x equals, I think, 5. So your answer is 5, 3. Let's look at it on Desmos. So I got x minus 6y equals negative 13. X minus 6y equals negative 13. And the next one was 4x minus 6y equals 2. 4x minus 6y equals 2. And if you look over here, where those things intersect, that would be at 5, 3, the same thing that we got over here.